So for this problem it says, someone throws a rock straight down from a 250-meter cliff. If it takes 5 seconds for the rock to hit the ground, how fast is the rock moving right before it hits the ground? So again, the first thing we want to do is write down what we're given in the problem. So it's saying, someone throws a rock straight down from a 250-meter cliff. So we can use the height of the cliff as our initial position then. So it's going to be your DI. So initially the rock is going to be at the top of the cliff at 250 meters. And then the rock is going to be thrown down to the ground. So at the ground, we could assume that that is going to be your final position. So it's going to be DF. And at the ground, we call that 0 meters. So let's write this down for our givens. And then for the rest of the problem, it says it takes 5 seconds for the rock to hit the ground. So the time t is going to be 5 seconds. So then it says, how fast is the rock moving right before it hits the ground? So we're trying to find the final velocity. So the final velocity is going to be right before it hits the ground. So in this case, we don't know the initial velocity that the rock's being thrown at. So we're trying to find VF, the final velocity. But there is also one other thing we know here. So typically, we're given the acceleration and we're trying to find it. And for the last 3 problems, we had an object moving on the ground. In this case, we have an object in free fall. So basically the object is starting above the ground and it's falling to the ground. So that means we're going to have the force of gravity acting downward on it. And the force of gravity is going to have an acceleration of negative 9.81. So we're going to use that for the acceleration. So we're also given an acceleration of negative 9.81 meters per second squared. And again, that's acceleration of gravity. And it has to be negative because gravity acts downward. So we have our givens, and we're trying to find VF. So we can look for an equation that contains all these variables. And it looks like we cannot find just one equation that contains everything. So what we can do is we can, like we did in the last problem, we can find 2 equations and solve for the 2 unknowns that we have. So let's see, so we can look at this equation here. So we don't know what VF is, we don't know what VI is, but we know what A and T are because we're given those variables. So we're trying to find VF, we don't know VI, so we can look for another equation that contains VI and all the other variables in that equation would be given to us. So is there another equation that has those conditions? Well, if you look at the equation above it, this one right here, so we know DI, we know DF, we know T, and we know A. So we could solve for what VI is because we know all the other variables in this equation. So let's do that then. So let's use this first equation right here, solve for VI, and then use the equation below it, plug in the value for VI, and we already know A and T, so we could solve for VF. So I'll write the first equation that starts with DF equals DI. We'll write that out first. And again, we're solving for VI. So we just want to rearrange this algebraically to solve for VI. So we already know that df is equal to 0, so we could just cross it off and mark it as 0. And now let's solve for VI. So what I did was I just moved the di to the other side and then moved the 1/2 a t squared to the other side. So I have VIT left on the left-hand side. So I could just divide both sides by t. So then the t's on the left cancel, and I have a division by t on the right side. So now I know what VI is in terms of all the given variables, so I can plug in those given variables then. So now if I plug this into a calculator, I'm going to get negative 25.5 meters per second. So that gives the initial velocity. So we have initial velocity. Now we can use the second equation, Vf is equal to Vi plus At, to solve for Vf. Because we know initial velocity now, we know A and T because we're given those variables, so we can solve for what Vf is. And again, I'm just going to plug in the variables now. And if I put this on a calculator, I'm going to get negative 74.6 meters per second. So that's going to be my final velocity. Now, the initial velocity and the final velocity are both negative because you're throwing it downward with some initial velocity. So since the initial velocity is downward, it's going to be negative. So we're assuming up is positive and down is negative. So if the initial velocity is negative and the acceleration of gravity is acting downward on it, it's going to become more negative. So that's why the initial velocity and the final velocity are both negative. It's due to the downward motion of the initial velocity and then the downward acceleration of gravity.